Okay, so the first thing you should do is read and understand your problem. Our question asks, determine how many of these are polar. And they give you 5 molecules. They give you SO3, OF2, BeCl2, CCl4, and O3. And so there's 3 steps to determine if something is polar or nonpolar. And the first thing you should do is draw your Lewis structure. And once you have drawn the correct Lewis structure, you should then identify the bond dipoles using your electronegativity chart. And the third final step is to identify the net molecular dipoles based on the molecular geometry of the molecule. And once you do all 3 of these steps, you will then be able to determine if the molecule is polar or nonpolar. So we're going to start with our first molecule, SO3, and the first thing we want to do is to draw the Lewis structure for this. So what you do to start out is you count the valence electrons of this molecule. So S has 6 and O also has 6, but there's 3 O's, so you have a total of 24 electrons. Okay, so now you're just going to start drawing your structure. So you put your S in the middle and you put your 3 O's around it. So you start with single bonds until and then we're going to fill in our outsides first. So this is 2, 4, 6 electrons, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, now that all of the outside elements have a full octet, you want to make sure the middle one now has an octet. So it actually doesn't. So you can take two electrons from right here and make a double bond with the S, and now it has 2, 4, 6, 8. So now the center atom now has a full octet, and this structure actually has resonance, which means that you can make your double bond here, you can make your double bond here, or you can even make your double bond here. Okay, so the next thing you should do is to draw your dipoles. And so when you look at your electronegativity chart and you find that S has an electronegativity value of 2.5 and O has a value of 3.5. So that means that the S is going to have a more positive charge and the O's are going to have a more negative charge. So when you draw your little dipoles, you do your positive end in the middle, pointing out towards the more negative, and then you start at the same spot for the other side and you drag it over there. Make sure that these are equal in length, and make sure that you also start them at the same spot. And then for the one down here, you just try to make those the same length. This one's a little shorter. There you go. Okay, so your third step is to find out your net molecular dipoles. And so this is what it's going to look like. Your molecular geometry, and it is trigonal planar. And you can figure that out by it has 3 bonds, and all 3 of those bonds are the same. They're all bonding bonds. That you don't have any non-bonding pair of electrons. So that means that you have a trigonal planar, and so all your dipoles are going to start in the middle at the middle S and point out towards the O. And they're all going to be equal in length, and they're also all going to cancel because they are all the same. So then you can determine that this is a non-polar bond. Okay, so you're going to go to your second molecule, which is OF2, and it has a total of 20 valence electrons. So you're going to draw your Lewis structure, which I already have done. So I'll walk you through again. So you start with your single bonds, and then you go to the outsides to make sure they have full octets. So you got 2, 4, 6, 8, 10, 12, 14, 16. You still have 20 minus 16, you still have 4 more valence electrons. So you place those 4 on the center atom, also making a full octet for the center atom. So all the atoms are happy now. And so then the second step is to draw your bond dipoles using your electronegativity chart. So F actually has the highest electronegativity. So you're going to start your tail in the center, your more positive end. You're going to go out towards the more negative end. You're going to do the same thing for the other side. Try to keep those equal. Okay, that looks equal. All right, those are your 2 bond dipoles. Okay, so our third step would be to identify the net molecular dipoles and the molecular geometry of the molecule. So we have 4 domains, 1, 2, 3, 4. 2 of them are non-bonding, so that is going to give us a structure of bent. And so this is what our structure looks like. So you have 2 bonding bonds, and then these 2 up here are your non-bonding bonds, and your dipoles are pointing down towards your higher electronegativity F's. And so since all the bonds are different, you have 2 non-bonding and 2 bonding, that means that this one is going to be polar, and your net dipole is going to be pointing downward. Okay, so here is your third molecule, and it's BeCl2. It has a total of 16 valence electrons. The weird thing about this Lewis structure is that Be doesn't have to follow that octet rule. So this Lewis structure looks incomplete, but it's actually the correct Lewis structure for this molecule. Okay, so then you're going to draw your dipoles, which I've already done for you. So Cl has a higher electronegativity value, so your positive end is going to be at Be, pointing out towards the more negative value. And this has 2 domains, and they're both the same, so this is going to be a linear structure, which linear, I wrote it over there. And so this is going to look, its molecular geometry is going to look exactly like this. And there's no net dipoles because they are equal in length, so they're going to cancel. They're the same and equal in length, so they're going to cancel, and that makes this molecule non-polar. And there's no net dipole because they cancel. Okay, so here's our 4th molecule. It is CCl4. You have 32 total valence electrons for this molecule. So you draw your Lewis structure just like before, with single bonds, and then filling the outside octets, and then filling this one just happened to fulfill its octet rule by just single bonds everywhere, so that's good. So the next thing you're going to do is to draw your dipoles. So Cl has a more negative electronegativity value than C, so you're going to have your positive tails here, go out like that, draw them all the way around like that. There you go. They're all going to be equal in length. It is 4 domains, all bonding, no non-bonding, so it's going to be a tetrahedral. And so your molecular geometry is going to look just like this. You have no net dipole because all the dipoles are going to cancel. And so since you have no net dipole and they all cancel, this is going to be a non-polar molecule. Okay, so this is our 5th and final molecule. It's O3, it's ozone. It has a total of 18 valence electrons. This one's a little different because all the atoms are the same thing, so there actually will not be, any dipoles because one cannot necessarily be more positive or more negative than the other because they are the same thing. So you end up with a double bond on this side and a single bond on this side, and then you have a non-bonding pair of electrons on the center atom. So again, there's no dipoles because they are the same element all the way across. So you have 3 domains. You have 1 non-bonding, so you have a bent structure, and it looks like this. You have a double bond on this side, you have a single bond on this side, and you have a non-bonding pair attached to the central atom. And so there are no net dipoles, but that does not mean in this case that it is nonpolar, because all the bonds are not the same. You have a non-bonding right here, and then you have two bonding. So this one is actually going to be a polar bond, despite the fact that there is no dipoles. Okay, so now we're going to go back to the beginning and answer the question that was given to us. So how many of these are polar? First one was nonpolar, second one was polar, third one was nonpolar, fourth one was nonpolar, and the last one was polar. So the answer is two of these were polar, and that was OF2 and O3. Some common mistakes for problems like these are not drawing your Lewis structures correctly in the very beginning. This can mess up your entire problem. If you don't have the Lewis structure right, you won't get the correct net molecular dipoles, and you also won't get the correct molecular geometry. So just really focus on getting those Lewis structures correct the first time. Double check them if you need to, so you can get those easy points.